What is greatest common divisor? The greatest common divisor of two positive integers, a and b, is the largest positive integer, which divides both a and b. One interesting property is that if two numbers, they're prime, their divisors will be just 1. Prime numbers are numbers which do not have a common factor other than 1. Let's take a look on some of the examples. Let's say we have 8 and 4. And first of all, they are positive, they're not negative integers. First thing we should do, we are going to list down the factors of each of these numbers. If you divide 8, the factors of 8 is 1, 2, 4, and 8. For 4, it's 1, 2, and 4. The greatest common divisor should be this one. Let's see, the largest positive integer is 4, and so is the GCD. Example 2, let's take now another two numbers, but this time we want big numbers like 64 and 86. 64 is, these are the factors, 1, 2, 4, 8, 16, 32, and 64. And these are the factors for 68. So if you look at all these two numbers, the only common greatest factors, we have 1 and 2, but of course we're looking for the 2 is the common greatest factor. So the GCD is, let's try these two numbers. If these two numbers do not have a common factor, the only common factor is going to be 1, and therefore this means that these two are coprime or prime numbers. You also should know that not all the time you can do this. Sometimes if you have a really big numbers, you cannot list down all the factors. There's another method for Euclidean method that can be used to get the GCD, but we're not going to cover the Euclidean method. Number 2, as we said from the beginning of this slideshow, we said that we're going to present about modular arithmetic. Modular arithmetic is basically a system where numbers wrap around upon reaching a certain value, which is some of the examples. A familiar use of modular arithmetic is in the 12-hour clock, in which the day is divided into 12 hours period. Think about it, and we are at 9, 4 hours later, we don't say 13, we say 1. It reaches 12. Instead of becoming 13, it starts from 1 again. So 12 here is the modulus. That number, when we wrap around, we start again from 0. This is a note here. The modular is just a remainder, and for example, you can see later on we'll see that a mod of a number is going to be the remainder times the quotient. But don't worry about this. We are going to understand as we move. And let's look at some of the examples. These are the rules here on top. They will make calculations easy if you understand these rules. Like a mod, if a same number of the same number is always 0. A mod B is equal to A if A is less than B. Look at some numbers. 7 mod 12 is 7. This means if I take 7, I divide by 12, I put 0, and then the remainder is going to be 7. 12 mod 12, it is 0. As we said, modulus is a clock. It reaches 12, it wraps around. It doesn't continue 12, 13. Instead, it starts from 0. Meaning, which is allowed is numbers from 0 to 11. Any number which is above that, it will wrap around between the 0 and 11. Let's try now mod 12. If we use the two properties that we said here, you can see that 22 can be divided into 12 and 10. So it is equivalent. This mod is the same as if 12 mod 12, which is going to give us 0 based on this property, plus 10 mod 12 is going to give us 10. So altogether, if you add this, it's going to be 10. 22 to mod 12 is 10. Another example with some bigger numbers. Every time you have to do a modulus question, you don't have to draw a clock or to go through all the boring stuff that we've been saying above. You can just use trick to find out what is the mod of the two numbers. So for example, we have 134 and we have a 134 divided by 89. This is what you get from the machine. So the easiest way to find a mod from this is, of course, to take the remainder, multiply the divisor. Like we take q, multiply the divisor. Remember the formula we were going to explain. If I take this one divide this, I will get the remainder of 0.506179778, right? This remainder multiply the divisor, I will get 45. So this is the mod